are again. It's been a while, but we run into a big hurdle that we had to overcome. And, we did a lot of testing and trials and stuff since the last time, but we finally got 3 horns that we're pretty happy with. All in all, we're still going to build some more later, and we're going to do a better flare, a more durable flare. And we want to thank a lot of you YouTubers out there that we've watched your videos and got a lot of hints and tips and things to try and things to test along the way. There's a couple I want to really give a shout out to is Mr. Harold Mead. He's the one that spawned the flare of these bells. He has a really good video on how to make them out of fiberglass, which we're going to entertain for our next build. The next guy is Aaron Douglas. He had a good video. He built a K5, and a few tidbits he gave us on the opening of the bells is what spawned us to try to make these bells open when they're supposed to. However, we're still not sure on the opening formations they're supposed to open. We watched a video of a guy tuned an M5 in a field, and he started out with a high bell and went to the low with lower pressure, so we assume that they're supposed to open low to high. We're really not sure about that, but we can't really find the information to explain that. But one thing, we've made some changes in the build of our fire chambers from the last videos you've seen. What we've done, we're still using the same diaphragms. However, we run into a problem on the K5. We just couldn't get high enough on the number 5 bell. And what had happened, we compressed so much that when the diaphragms came together, it actually touched the back one, built up air pressure and seized off. So we had to figure out a way to keep that from happening. So our first thing we did, we cut a small sliver of PVC pipe, placed in between the two, and used the same rubber that we had in the front and the back. And that seemed to work okay, but we wanted to find a better way. So what we did, we located some rubber, just some 1/8 inch solid flexible rubber, drew it out on here, and we cut us a gasket out of it with a pair of 10 snips, and that's what we are now in all 3 of these horns. We went ahead and rebuilt this one from the last because we like this so well, but it is a little bit more temperamental and it's not as builder friendly as our first version. But this, we're really happy with the way this works out. So we took the rubber gasket in between the 2 diaphragms and our same rubber that we used previously in the front and the back, and then we compressed them by 3/8 of an inch, which is super tight. So here, if you want to know what the rubber, the previous one and this one is, here it is right here. You can find all this stuff online. And as you see, we tune in standard tuning, 440 hertz in the A, where the C is 261.626 hertz. And our former method of tuning, these things here are dangerously loud. And it got so loud that our amp was just not loud enough to tune. So we found an app online. I think the app's called G-Strings. That's actually pretty accurate, and we're really impressed with how it works, and that's how we tuned all these bells. So now we'll get to it and show you how we went about making these bells open the way that we wanted them to. We've already tuned this one. We're going to try to show you in reverse. First thing we did is we started out with an 11-inch piece of pipe on our low bell, and we reduced the size by 1.5 inches of each one. Now, if you're building a 3 bell or a 3 chime, you want to overlook the number 3 bell, because in all 3 of these, the three chime of this is the 1, 2, and a 4 bell. But once we did that, the open pipe, we went ahead and set all these diaphragms at 10 pounds like we normally did, and got a good buzz out of it. And then we repurposed this, which we did some testing on our air pressure flow. And the way we did this is, now once we get them all set with straight pipe, we come in here and you plug your number 5 bell into there and your 4 bell into here. Slowly crank your regulator, and what you want is this bell to open just previous to this. If it doesn't, you loosen it up just a hair where it opens just ahead of this one with your regulator. We'll show you what we're talking about. Whoops, let me turn it on here. Slowly increase the pressure. Now here, number 4. And you see how that did? So once we did that, then we replaced the number 5 bell with the number 4 bell, or the 3 bell, and did the same routine. Now, this bell should open just previous to this one. There it is, it's sounding off. And what you can achieve by doing that, we did all the straight pipe, just like that, with straight pipe, and then at that point we put a temporary mark on here. Well, then we went back and tuned all of these with just straight pipe to get us closer, and we redid that same procedure to get it a little closer. And then at that point you just retune, start with your 5. We was going from the 1 up, but we discovered it's better to go from your high bell down. But anyway, we want to show you on the M5 over here, all 3 of these act like this, and if you want some good low end feathering, this is what we ended up with. You see that the number 1 bell opens first. That's just a little bit there. We'll show you the K5 will do the same thing. That's just a little bit there. It's about 60 pounds of pressure. Extremely loud. We're here in the garage, which intensifies the sound or whatever. And if you want a good, we played around a little bit with, if you want to play with the feathering of the build up and the fade off, we learned that you can run like a 6 to 8 foot piece of pipe between your valve and your horn, and the pressure in the container, you know, about 25 cubic inches or so. That'll give you a real nice effect on the fade off end, which we haven't got that here. We may explore with that a little later. But anyway, we're going to take these out in the field, get the meter out, show you what they'll do, and hopefully enjoy the video and tune back in. Thanks for watching.